topic, what this is all about is air pressure. So what it's showing you is why these balloons are are being pushed outwards due to air pressure. Now, what causes air pressure is pretty much the same thing that causes air resistance. Now, the difference, these air particles are moving around all over the place, and because they're contained within the inside of this rubber balloon, as they move around, they bang into the sides, and this keeps the whole thing pushed outwards, so it can never deflate. If I can actually change, if I can actually change how many atoms there are, and if I change the type of atoms, you can see that they're banging around and pushing against the sides, and this is how air pressure happens. So how is it similar with air resistance? So let's see if I can work out how to demonstrate this on a whiteboard. So I'm going to stop sharing. I'm going to stop the video for a moment. Pause it. Okay, so here's a load of these are air particles. Now they're frozen in time. They're not moving anywhere. Of course, they in reality they would be moving places, and if there was a draft, if there was a gust of wind, they would all move sort of together in one direction. But when there's no wind, they are still moving around. So let's imagine we had just this random rectangle, and we'll color it in a different color, like that, and we'll give it an arrow to show that it's moving. So that's moving towards the right. Let's make the arrow blue. So I'm going to put it on it, actually. Yeah. So this is just demonstrating this object is moving towards the right-hand side. Now, as you can see, if it did move towards the right-hand side like this, eventually it's going to come into contact with an air particle, and it would have to push the air particle out of the way. It would bang into it, and the air particle would move out of the way like this, and then it would carry on going. And now it's going to push a few more air particles out of the way, like that, right? Now, in reality, there's a lot more air particles than what I've drawn. There's millions and millions and millions, even between your two fingers. When you hold your two fingers apart like that, a finger and thumb, there's millions and millions and millions and millions of air particles just between your finger and thumb. So when you're walking down the street, even, you are having to push by just billions and billions of air particles as you just walk by the street. So if I was and maybe the force, we could say, the force that I have to push is down to how many air particles I have to push out of the way per second. So and you can think about it as whether I'm walking through the air particles or the air particles are moving towards me, it's kind of the same thing. It doesn't make much of a difference. It's either I'm moving towards the air particles or the air particles are moving towards me. And either way, it would feel in a very similar way. So let's just turn the underline off and the bold. As I walk down the street, I have to push billions of air particles out of the way. Okay? Every second. It doesn't. But it's very easy, isn't it? I don't have much of a problem walking down the street. I don't even notice it. I don't get tired pushing these air particles out of the way because they're very, very, very light. Even though I'm pushing billions, they're very, very light. So the faster I walk, the more air particles I come into contact with every second. Can you see that? If this thing was moving slowly, it would just push away the odd air particle every now and again. But if it moved really quickly, then it would have to push a lot out of the way a lot more quickly. So, and this this would cause a greater force and would be more noticeable. So you know when you're cycling, like I say, you're cycling very, very fast, and you can actually feel the air pushing you because you're pushing a lot more out of the way, a lot more quickly. So another way that you could increase the number of air particles you need to push by every second is if you increase the surface area. So you could also increase the air resistance by increasing surface area. If you've got a larger surface area, then again you're going to push a lot more air particles out of the way. So let's demonstrate it with this block here. If this was had a larger surface area like that, now even when it's moving more slowly, it's going to be pushing a lot more air particles out of the way, right? So like if you got your hand and you opened it wide and you tried to push water out of the way, it's a lot harder than when you cut through the water with your fingertips. And that's why when you learn to swim, then if you're pushing your hand forwards, then you slice through the water with the tips of your fingers, and when you're pushing hands backwards, because you then use your hand like a paddle and you make it flat and you push the water back. So that's how you move yourself through the water. And water is works in a very similar way to air. Of course, the particles in water are a lot closer together, and so it's a lot more noticeable. If you just walking underwater is quite hard, whereas walking in air is fairly easy. So that is what causes air resistance. So in summary, air resistance will increase with increasing, then we can go surface area or speed. Okay. There are other ways of increasing the air resistance, but for now we'll just say those two examples. Okay. So that's a basic, and we're going to learn some other things about air resistance in a moment, but let's just stop the video there.